Lesson 1.9, Introduction to Parent Functions. Please write down the essential question. How do I find the equation, graph, domain, and range from a parent function? Please watch this video and take notes very carefully because on the test for Chapter 1, you will have to recreate the different parent functions and be able to determine what is the equation and what does the graph look like. Who uses this? Oceanographers use transformations of parent functions to approximate data sets such as wave height versus wind speed. We're not talking about transformations in this lesson, but we will be down the road. And basically, we're talking about the parent function. And the nice thing is, if you know the parent function, you can do transformations or change those parent functions to create new functions. Functions can be classified into families of functions. The parent function is the simplest function with the defining characteristics of the family. So we're going to start with linear. And the equation for linear is y equals mx plus b. When you're dealing with the parent function, the slope is 1 and the y-intercept is 0. Thus, the equation is y equals x. So when we graph that, let's do that now. Oops. Come on. Why is this staying on here? There we go. Okay. So when we graph this, trying to get the pen off. There we go. Okay. Well, think about it. No matter what x you pick, the y is going to equal it. So graphing that is going to be 1, 1, 2, 2, 0, 0, -1, -1. I'm just making up these points. -2, -2. If you're confused, it's just like we're making a table. If x is 0, y is 0. If x is 1, y is 1. If x is -1, y is -1, and so forth. 2, 2, -2, -2. So then when we graph that, it's going to look like this. It's just a line that goes right through 0, 0, and that's what the graph of a linear function is. When we're talking domain and range, the domain is going to be -infinity to infinity, and the range is also -infinity to infinity. When we're talking about domain, we're looking at what happens on the graph when we go from left to right. And when we're talking about range, we want to talk about what happens when we go down to up. So when I look at this graph, this line is going to be going to the left forever. That's -infinity. And to the right forever. That's infinity. Also, the graph is going to go down forever and up forever. So that's why the range is -infinity to infinity. The video questions are here. Truly, they shouldn't be on this page, but we will come back to that at the end of the video. Consider the two data points, 0, 0, and 1, 1. If you plot them on a coordinate plane, you might very well think that they are part of a linear function. In fact, they belong to each of the parent functions below. And so we're going to talk about each of these parent functions right now today. And we will make sure that 0, 0 and 1, 1 are points that we put on each of these. All right. So absolute value looks like this. Y equals the absolute value of x. To graph it, we're going to just make a little table. And I'm really going to pick 3 points, maybe 4. It depends on the graph. So if I start at 0, the absolute value of 0 is 0. If I pick 1, the absolute value of 1 is 1. If I pick -1, the absolute value of -1 is 1. I'm just choosing easy x values, and I usually always choose 0, 1, and -1. And if you recall, we have to pick 0 and we have to pick 1 because we're considering those two data points, and we're showing that they're going to appear on all of these parent functions. So if I graph this right now, 0, 0 is right there. 1, 1 is right there, and negative 1, 1 is right there. What this is this is a V. Make sure you don't do a curve there. We're going to talk about that when we get to quadratic. That is a V. So now let's talk about the domain and range. Remember, the domain is what's happening going from left to right, and the range is what's happening looking at the graph down to up. All right, so let's talk about this right now. The domain and the range for the absolute value function. Well, when I look at this graph from left to right, this arrow is going to go to the left forever, and this arrow is going to go to the right forever. So I know that my domain is negative infinity to infinity. The range is different. Remember, the range, we look at what's happening going from down to up. Well, the graph does not go below the x-axis, meaning that the range or the y values will never be negative. They're starting at 0, and so we're going to use a bracket because it includes 0, and they're going up forever. That's infinity. And that would be the range. Okay, let's scroll down and let's look at quadratic. And again, at any time, you can stop the video to catch up. Y equals x squared. So let's make our table. We already know we have to do 0 and 1 as our x's. Well, plugging 0 in there, 0 squared is 0. 1 squared is 1. So far, trying to scroll up here, 0, 0, 1, 1 have been on both the absolute value and are going to be on the quadratic function. Well, let's do one more. Let's do negative 1. If I square a negative 1, that's a positive. And now we're going to graph it. 0, 0 is right there. 1, 1 over 1, up 1. And negative 1, up 1. Oh, well, this kind of looks a lot like absolute value. Yes, however, it's not a sharp corner at 0, 0 or a V. It is a curve. So you have to make sure when you do this that you have a curve, just like that. Make sure that's very clear. I do see the difference. That's a V, that's a curve. You will get this wrong if you mess those two up. All right, let's talk about the domain and the range. Again, the domain is left to right. Again, here, my arrows, yep, I see they're going up, but they're going to the left and to the right forever. So that's negative infinity to infinity. And you can tell that by looking at the function. Any x value on the real number line will work in here and in here. That's why the domain was negative infinity to infinity. But the range is different because you're never going to get negative values because you're squaring an x, which means that you're going to get all positives. So again, the range is 0 to infinity. Well, this is kind of cool. Absolute value quadratic. The domain and the range are identical. Remember, the range are your possible y values. This graph is not going below the x-axis, so the y's will always be positive. Let's move on to cubic. That is going to be y equals x cubed, thus cubic. All right, let's make our table. If I plug in 0, 0 cubed is 0. If I plug in 1, 1 cubed is 1. And if I plug in negative 1 cubed is negative 1. All right, let's graph this. 0, 0, 1, 1, negative 1, negative 1. So you might say, well, this looks like a line. Well, if we kept doing more points on this, you would see that this is what a cubic looks like. It's like a curve. It comes down like this, goes through 0, 0, and curves back around. That's what a cubic looks like, just like that. The domain and the range. The domain is going to be negative infinity to infinity, because looking at the graph from left to right and looking at our parent function, every x on the real number line will work. That's why I'm saying domain is negative infinity to infinity. Also on the cubic, the range is also negative infinity to infinity. Again, the graph is going to go down forever and up forever. So that's the domain and range of the cubic. The rational, y equals 1 over x. So here's a little problem. 0, 0 is not going to work, because if I plug 0 in for x, I'm dividing by 0, and that's undefined. So x cannot equal 0, and also y will never equal 0, because 1 divided by whatever will never give me 0. What we just created are two asymptotes. A vertical asymptote, which is going to be x equals 0. That's what that is. And a horizontal asymptote, which is going to be y equals 0. These are called, I'm going to write this down, asymptotes, and we will talk more about asymptotes later. All right, so now if we're going to graph this, 1, 1 for sure will work. 1 divided by 1 is 1. And now negative 1, that's the y value is negative 1. 1 divided by negative 1 is negative 1. I'm going to just try some other points to show you how the graph looks like it looks. If I pick an x value of 5, 1 over 5 is 1/5, or negative 5, 1 over negative 5 is negative 1/5. And now if I graph this, I'm going to get 1, 1. You know what? I am going to graph it in green because I did my asymptote in red. Okay, 1, 1 is right there. Negative 1, negative 1 is right there. 5, 1, 2, 3, 4, 5, up 1/5 is about right there. And 1, 2, 3, 4, 5, negative 5 down is about right there. So what you're going to learn about asymptotes later on is that a graph can never touch or cross an asymptote. It just hugs it. So I'm going to hug the asymptote. I'm going to go through that point. I'm going to hug the asymptote and go through that point, but I never touched it or crossed it. Same thing here. I'm hugging the asymptote. I'm turning because I need to go through that point, and I'm hugging the asymptote, and there we go. That is a rational function. The domain and the range. The domain is going to be negative infinity to infinity. We got to think about that right now. Oh, I know why. Okay. I think how we have to set this up, that is not going to be true. I'm going to take that away for a moment because we can't say that. We can't say that because we're not including x equals 0 or y equals 0. So when we look at this graph from left to right, yes, my graph is going to negative infinity, but how we're going to have to write the domain is negative infinity, comma, 0, and then a parenthesis because we're not including 0. And then we're also going to have to say 0, comma, infinity. We have to set it up like that. We can't say negative infinity to infinity because we can't include 0. Range is the same thing. Negative infinity, comma, 0, 0, comma, infinity. Because of the asymptotes. So that is the domain and range. And we'll talk more about that in class. But as you can see, I'm saying negative infinity because the graph is going to the left forever and the graph is going to the right forever. That's what these are. The graph is going down forever. The graph is going up forever. But I have to do a pause at the 0 because that is not counted in the domain and range because it's an asymptote. All right, last one, radical. Y equals the square root of x. And 0, 0 will work because you plug in 0. Square root of 0 is 0. 1. Square root of 1 is 1. Ooh, no negative numbers because you can't take the square root of a negative because then you get an irrational, and we don't want that. We want, or not irrational, imaginary, and we don't want that. Then let's try 4. The square root of 4 is 2. So I can't use any negative numbers because, like I said, that will be an imaginary number, and we're going to talk about that later because you can't take a square root of a negative. All right, 0, 0, 1, 1, 1, 2, 3, 4, up 2. And the radical function is kind of like a little curve, just like that. And let's talk about the domain and range. I'll put those in green here. Domain and range. Well, obviously, the domain, it's starting at 0, going to infinity. There's no negative x values. And the range is also starting at 0 and going to infinity because there's no negative y values. So now I'm going to go back here. You should stop the video, answer the video questions in your notes, and we will see you later.